last example, example 6, where we're talking about mixtures. And so what I wrote up here first is to go ahead and write the differential equation for mixtures that we got from section 1.3, where our total amount of mixture, the differential, the change, is going to be equal to Rn minus R sub out. And so what we're going to do is we're going to do problem 25, but we're going to use the information in 23 to help us solve 25. 23 is going to be a homework problem. So solve problem 23 under the assumption that the solution is pumped out at a fast rate of 10 gallons per minute when the tank is empty. So we have a large tank filled to capacity with 500 gallons of pure water. Brine containing 2 pounds of salt per gallon is pumped into the tank at a rate of 5 gallons per minute. All right. And so for our Rn, we have 2 pounds of salt per gallon times 5 gallons at the rate of 5 gallons per minute. And so we're getting 10 pounds per minute. Then for our tank being pumped out, instead of it being pumped out at the same rate as is in 23, we're looking at it as being pumped out at a fast rate of 10 gallons per minute. So we're going to take our total, which is going to be the total amount of mixture over 500, but then minus, since it's being pumped out at a rate of 10 gallons per minute, as opposed to coming in 10 gallons, we're going to have a minus 5t because the difference is 5. And so the more time goes on, after 1 minute, we're going to lose 5 gallons from the 500. After 2 minutes, we're going to be losing 10 gallons. So that's why we have our amount. It's going to be A divided by 500 minus 5t times the 10 gallons per minute that's going out. So 10 gallons per minute. It should be right there. And then that's the amount of pounds per gallon of salt. And so we're going to get 10 over 500 minus 5t. All right, now what we want to do is go ahead and write this as the differential equation. dA over dt is equal to our R sub n is 10 pounds per minute. I'll just go ahead and write 10 minus our R out, which is 10 over 500 minus 5t, or 2 over 100 minus t, because everything is divisible by 10 in that. So we have our our 2a. We have our differential equation, so there should be an a there for total amount. So sorry for not putting that there. All right, so now dA over dt is equal to 10 minus 2a over 100 minus t. And now we want to, what we want to do is we want to solve this differential equation. We want to find, how can we find the total amount that's in there, and then how can we find when the tank's empty? So we're going to have to solve this differential equation to find total amount. Now, solving this differential equation is not a separation of variables like the other, because I have an a in the numerator, t in the denominator, with that 10 minus on the out, or the 10 on the outside by a plus or minus. So I can't use separation of variables, but I can turn this into a linear equation. So we have dA over dt plus 2a over 100 minus t is equal to 10. Now what we want to do is we want to solve this differential equation. We notice, this is a linear equation where my a can be written on the side as like so, and then I can set this up and solve this by solving a linear differential equation. And so I need to find my integrating factor. So the integrating factor is the value that is with the dependent variable, and so 2 over 100 minus t, and we're going to raise that, put that in the exponent for an exponential. Now we're going to solve this exponential, or this integral, and we're going to put the 2 on the outside, and notice, hey, that's going to be natural log. So 2 natural log of 100 minus t, but the derivative of the inside is negative, so I got to put a negative on the outside. And so there's our integrating factor, but we can also change this to be e to the natural log of 100 minus t to the negative 2 power. And so then we're just really looking at 100 minus t to the negative 2 power. So there's our integrating factor. We're going to put that on the left side with a. So 100 minus t times negative 2a is equal to, then we're going to multiply the right. Now on the left side, that's the derivative, and we take the integral. So we're not going to have to really take the integral to the left side, but we are on the right side. So let's go ahead and take the integral with respect to t on the right. When we do this, we're going to get 100 minus t raised to the negative 1 power. The derivative of the inside's going to be negative, so there's two negatives. So that 10 that's on the outside is just going to stay 10 plus c. And on the right-hand side, we still have 100 minus t to the negative 2 times a. Now, to get rid of this, to get the a by itself, we're going to have to multiply both sides by 100 minus t to the second power. So let's go ahead and do that. So we have 100 minus t squared. We're just going to multiply that through to 10 times 100 minus t to the negative 1 plus c. All right, when we do that, we're going to solve for a. A is going to be 10 times 100 minus t plus c times 100 minus t squared. Now, what we want to do is we want to find, let me go ahead and make sure that this is a c and add another parentheses. All right, so now what we want to do is we want to be able to find, okay, we need to find the c. We need to find that constant. If we can find that constant, then we can, have our equation for total amount. Well, we know one thing, that there's 500 at a sub 0. There are 500 gallons in the tank, all right? So what we're going to do is we're going to go ahead and set that equal to our equation, where that's going to be, let me change this up to just have a different color. So we know that a sub 0 is going to be 500, and that's equal to our equation, 10 times 100 minus t plus c times 100 minus t squared. Now, we want to solve for t. We're going to plug in 0 for everywhere that we have a t. So we have 0, 0. And so we're going to be given 500 is going to be 10 times 100, which is 1,000, plus c times 100 squared. So I'm going to subtract 1,000 and get minus 500, and that's equal to 10,000 plus c. So I'm going to divide both sides by 10,000. When I do that, I get c is equal to negative 1 over 20. All right, so now I know what c is. I can plug this into my equation. So a of t is equal to, and then go down to my formula. I believe it was 10 times 100 plus t, 10 times 100 minus t. Plus, I'm sorry, now minus 1 over 20. And then we can say times 100 minus t squared. All right, so we want to find out, well, when do we have 0 for our total amount? So we're going to plug in 0. So 0 is equal to 10 times 100 minus t minus 1 over 20. 100 minus t squared. Again, you can use your graphing calculator to finish this all out, or you can choose to solve for t. When we do this, we're going to get t is equal to 100. So after 100 minutes, we are going to have an empty tank. Put minutes there. And that's it.